Okay, so next presentation from Andreas Faath about company specifications from the point of view of VDMA.
Okay, is this working? One, two. I can hear you. One? No? Okay. Okay, so yeah, welcome from my side. As mentioned, my name is Andreas Faath, coming from the VDMA, and what the VDM is and what we're doing in respect of OPC UA Companion specifications, I will explain you in the next 25 to 30 minutes. So at first, to start, the VDMA is a kind of global acting association founded 126 years in Germany, but now acting all over the world and representing the manufacturer industry. So for that we got more than 3,200 member companies, and those member companies are representing the broad range of the manufacturing industry, and for that we have a structure which is representing the different branches in the industry in 38 trade associations. That means what is pretty important, that the VDMA is, for example, not only covering the robotic industry or the tooling industry, we are covering really the broad range. So we are kind of an organizational umbrella which makes it possible to interact and to network really closely between different industry inside the manufacturing industry. We are right now an international acting organization. So we have, for example, offices in China, India, Japan, or Russia. And of course, there are other kinds of organizational stuff. And of course, what is pretty important, that we have a host of several European and global sector committees. And what that means, I will explain you also in the presentation. So what you have to keep in mind, and what is pretty important, that we as a VDMA, as I told you, are not only representing one branch inside the manufacturing industry, but representing the broad range in this industry. So we were looking for standardized interfaces. We were not aiming just to see there is a technology called OPC UA and we wanted to use it somehow. We were starting with the idea, and our member told us that standardized interfaces will be key to success. For that reason, we looked out for a technology who serves the needs they have. And one of the most important needs, for example, was that there should be a security by design approach, and of course a semantical machine description possible. So this is why we are taking OPC UA and why we are doing those companion specifications together with our members, and why we are hosting that. Because the big picture goal is really to have, in a dynamic, flexible, intelligent production, the possibility that machines and systems can collaborate, can work, can interact pretty easy by just describing themselves in the production. So, as you know, OPC UA is based on the OPC UA meta model with some built-in information models, and then OPC UA companion specifications and vendor-specific extensions are covering the needs of the industry and the individual companies. So the OPC Foundation is, of course, a partner from the VDMA in this case, because OPC UA is built and developed by the OPC Foundation, and the OPC UA companion specification is what the VDMA is going for. So the difference, and also the reason why your machines are not replaceable by just taking a standardized interface, is that there are vendor-specific extensions. That means what we are doing is kind of the fact what you did some years ago when your remote control broke down. You went to an electronic market and you bought a universal remote control. And on that universal remote control, you have basic functionalities like 0 to 9, program shifting, volume shifting, and so on. And this is exactly what we are doing in these OPC UA companion specifications. So the companies are meeting in the VDMA and discussing what are the basic information, the basic functionalities we can standardize without making the product that transparent that the market relevant differences then, are not even more existent. This is what we have in the vendor specific extensions, where, for example, Samsung is having here a red dot, or Sony or Panasonic, and this red button is always doing another function for the different TV vendors. So this is how you can bring your market relevant information on top of the standardized basis. So what you see here is the actual overview of the VDMA associations, and you can see how far they are in the process of developing OPC UA Companion specifications and how far they are in awareness. So you see, I would say about 80% of the branches inside the machinery industry are somehow at minimum aware of OPC UA, and really a lot of them are right now in a companion specification work, and also some of them are right now joint working groups with the OPC Foundation and also have release candidates or release on the market. I will show you later in this presentation a short deep dive in machine vision, plastic rubber machinery, and robotics. And just to keep up to mind that here there is a world like, for example, integrated assembly solutions is not just one thing, one machine. Covered by integrated assembly solutions, for example, are end-of-arm tools. And end-of-arm tools are described in the working group here. And end-of-arm tools means that they are standardizing information models for grippers, for example, but also screwers. So everything you can imagine on the end of a robot arm is somehow handled here in the integrated assembly solutions group. So right now we got more than 450 companies who are actively developing OPC UA Companion specifications, and more than 26 working groups are right now inside the developing process. So of course those companion specifications don't fall from heaven. That means we have a process. And in this process we got 5 major steps, and I will explain you shortly the major steps as an example from the robotics group. So the robotics group preliminary work means they started about 2017 in February with a co-working group here, which is representing not only the manufacturers itself, but also, for example, the end users as VW here. And they were thinking about how should we get an OPC UA Companion specification developed for robots. And during the content work, they made clear that they have the goal that they want to have scalable, extensible information model which is independent of the robot type characteristics. That means if I ask you now to think of an image of a robot, I'm pretty sure that you have totally different robots in mind. Some of you maybe have a 3-axis robot, some of you maybe have 6-axis. So what they have to think of is how should we and how can we put on a more abstract level the development to cover all the different kinds of robots in one specification, and to cover all the industrial robots, mobile robots, and whatever there's on the market. So they figured out that they do a motion device, because all of your robots you have in your imagination, those are motion devices. The basic functionality and the most important functionality of that is doing a motion. So they called it motion devices, and if you have more than one motion device acting together, it's a motion device system. And they agreed, for example, as a lot of other working groups, to proceed stepwise. That means at the part 1, they were just going for vertical communication, getting information out of the robot for the use cases, for example, condition monitoring and asset management, and other use cases, and maybe, for example, state machines or control of the robot will follow in subsequent parts. So it's not like our specifications are covering the whole bunch of use cases which a machine can fulfill. It is more like a little bit detailed development of a specific field in the whole bunch of use cases, for example, a robot can fulfill. So Next step is to design that in OPC UA. And if you think about OPC UA, this is of course an information model. So they started to think, how should we describe a motion device? And a motion device can be described component-oriented because all the motion devices are somehow built up on the same components. And those components are the motion device itself. So we have here the motion device system, which can contain more than one motion device. Then we got always controllers and safety states. And on the example on motion devices, they thought about what are the components all motion devices have. And this is, of course, some parameters like the manufacturer name and so on, but also, most important, axis and powertrains. So they did an axis identifier object type, where, for example, a motion profile or a parameter set is inside. And also for the powertrain type, they have a motor type and a gear type. So now you can see, if you have, for example, 3 axes, you just can take the axis type and instantiate that 3 times. So you can represent your axis independent from the robot manufacturer in the same way using the information model. And all the variables, of course, are pub/sub capable, and also they derived a lot of variables and types directly from the device integration specification which is available. So this is one part here, as I told you, about condition monitoring and asset management. And they decided to do at the first step a component-oriented approach. How do we bring that into the publication? There's a homepage, and this homepage serves as a kind of basis for our working groups for self-description of the working groups. So each of the working group has its own short article representing themselves and telling you what is our goal, who we are, what do we want to do, what are maybe our next demonstrators or whatever. And secondhand, we have a download area for companion specifications. And in that download area, you can download, of course, the released specifications, but you can also download the release candidates. And for those release candidates, it's pretty important for us that you all give us comments, because we are here opening the process to public and asking the public for ideas, comments, whatever you want to give us as an advice. Because we want really to make sure that everybody who may take later on the companion specification has a possibility to bring his needs inside the specification and inside the development process. So check out which companion specifications and maybe release candidates are available here and give us the comments, and maybe we can bring that also in the specification before we release it. We bring that in the use in the industry, and what we were doing there is demonstrators. So the robotic group did a demonstrator which was shown first at Automatica Fair in summer 2018, and they were connecting robots which were live running on the booth from the specific vendor on the fair, connecting them using OPC UA and the companion specification to an interface on the Microsoft Azure Cloud. And there you could directly compare the live running information from the different vendors in one interface and directly check which motion profiles, for example, are right now running on the robot. And I talked to some developers, and as Stefan already said, they told me it took about 10 to 15 minutes to bring the information from the robot into this Microsoft Azure-based interface, so pretty fast. For consistency, this means that, of course, the different groups have their special interests, and this is all fine because you cannot describe all machines with the same information model, of course. But what we're trying to have is a more interoperable way between the different branches, so that information which is comparable for different branches, like, for example, injection molding machines and robots, both have a manufacturer. So it's critically important to find a way that both branches are describing the information on manufacturers the same way. So for that, we have a central coordination, and we are doing a lot of harmonization between the different companion specifications. And this exactly is where I said in the beginning, the VDMA serves as an umbrella for different branches. So right now we are mostly in this case, so doing companion specifications, information models for the specific branches inside the association. But where we are going to is that we have also the industry interoperable communication, so that in-common information will be defined the same way for all the different branches inside the manufacturing industry. And for internationalization, I will skip right now in the machine vision group, which is a total different approach from the component-oriented approach from robotics, because a machine vision system is not that easy to describe out of its components. So normally, and in this case a little bit different, but normally we have a collaboration together with the OPC Foundation. That means we got OPC UA as a technology, which is specified by OPC Foundation, and OPC UA is taking companion specifications to have standardized information. Those companion specifications are developed by our groups like OPC Machine Vision. And VDMA is hosting those groups, so we are not owning the groups, and we are also not owning the specifications because they are free of charge available for public. And the OPC Foundation is accepting those groups because we're doing joint working groups. That means if you're a member of VDMA or the OPC Foundation, you are able to join the groups, and not only to give us comments after the release candidate, but also during the development process right from the beginning. After we did the joint working group with the OPC Foundation, you can sit with a group, or you can phone with a group, or whatever. You can have the information and also develop the companion specification together with us. For machine vision, and this is what a lot of groups are doing, there is a more international approach. So it's not only VDMA and OPC Foundation, it's also, for example, in this case, the G3 organization. G3 is a global standardization initiative for machine vision. So there are international associations like from US, Japan, Spain, Germany, and China inside. And they directly started from the scratch as an international group with a promise to bring the machine vision system later into use in those areas of the world, and also hopefully in different areas of the world. So for that, they had more than 60 companies involved worldwide and more than 100 participants. So a big group with a core team and a total working group who were developing the specification for machine vision systems. And a machine vision as itself is any kind of smart camera, vision sensor, or complex machine vision system. So how do a specification, a standard, for such a broad range of the variety of machine vision systems? What they had in common is that they are changing electromagnetic waves using an image process tags into information. That means they are getting a picture, having a task to see, for example, here, where's a bottle opened, where's still closed, or where is a bottle missing. And from that, they are gaining information in the system. So as you can see, it's a lot of software-dependent processes here. And for that, they thought about what do we have in common. And what they had in common is that they all have a behavior, and they all have data management. So what does that mean? That means that they said we are all using configuration data or recipe data or even result data. And we cannot define how the results are represented. But we can say if we got result data, it can be managed always the same way. Means the data as itself is a black box, but the way you get the data out of the machine is standardized, and also the way how you get a recipe inside the machine vision system and all the configuration data inside the machine vision system is standardized without touching the recipe itself. And that means that there are mandatory objects, and for example, configuration management, recipe management, result management, safety set management, diagnostic level, and system states, it's all mandatory. So it is not of a kind like a machine vision maybe supports those data management standards if it has the OPC UA Companion specification on board. It's really like it's mandatory, so you can count on as a customer that all of those mandatory objects are implemented and instantiated in your machine vision system. And for the behavior, they developed a state machine. That means they developed or they thought about which states do all the machine vision systems has in common. And this is, of course, pre-operational, halted, operational, and error state. And also the transitions between the different states are described in the standards. And this top-level state machine, again, is mandatory. So if you're buying a machine vision system with the OPC UA Companion specification vision on it, there is a state machine implemented where you can directly see the states and compare the states from different machine vision systems running in your production, independent from the manufacturer. And behind the several states, there are more state machines which are on lower levels, which are then optional. So maybe a vision system can deliver those states behind the error state, maybe not, so it's optional, but this first level, top level state machine is mandatory always. So for plastic and rubber machinery, which is the last group, and this is also more application, is a more application approach. So we had the component-oriented approach for robotics, we had the more behavior and data management approach, and now we have a more API approach. So that means there are really a lot of specifications called Euromap. Euromap is also, again, in European sector committee like G3 for the world. Plastic and rubber machines have that for the market from Europe. So there are several specifications, and one specification which is somehow always included is Euromap 83. This Euromap 83 has general information on plastic and rubber machines. So that means that all the other specifications are deriving the general information on higher level without defining them again and again. So an identification or a manufacturer is defined in here, and it's just derived inside the Euromap 77 where those information are needed, of course. So Euromap 77 is between injection molding machine and MES. And there are a lot of Euromaps 82, so this is kind of a series, which are always having the injection molding machine together with a peripheral device. And on one time it's a temperature control device or a hot runner or LSR dosing system. So there will come even more specifications, but those are the first three who are right now released or a release candidate. And there is right now as a release candidate Euromap 79. So between injection molding machines and robots, there's also a specification which is exactly taking the needs for the interface into account for this configuration. And as I told you, there are a lot of specifications. There are even more. So that means there's also the Euromap 48. It's only one-time Euromap. And this 48 is always for interfaces between an extrusion line or extruder itself, again, between other peripheral devices like a hauler of a melt pump, a die, or some of the other ones. So there are also 11 specifications as a release candidate right now. And we have Euromap 86, which is the interface for material handling systems in the field of plastic and rubber machinery. So to come to an end, what is pretty important for us is that we are, as I told you, not having only the manufacturers. And in the case from Euromap 77, have an injection molding machine interface to MES. We have, of course, the MES suppliers, we have the injection molding machine manufacturers, we have the controller manufacturers, and we got one end user called Lego Systems. So it is really important for us to have also end customers and users inside the groups, because only they can really define what is needed. And it always has to be a kind of a mix of all stakeholders later on using the companion specification to get all the needs inside the specification. The EURMAP 77 use cases are, for example, basic machine information, machine status, job management, monitoring of process data, management of production data sets. And this is kind of representative for all the working groups. So we are always working based on use cases. It's not like just bringing variables information in a standard. It's always about thinking what should be the use case later on for the companion specification so that you can fulfill a use case later in adoption. And as a last central comment from my side is really what we really need to prevent as a kind of community is that we have, or that we cannot allow competitive standards on the market. So it's critically important for us and also for OPC Foundation that if you are thinking about doing companion specification, or if you are thinking about joining an OPC UA companion specification working group, please get in touch with the VDMA or the OPC Foundation, but don't stay in your, I don't know, backyard with some of the manufacturers and just do something and then bring it to the market. Let's work and collaborate here together, and as earlier we get in touch and collaborate, as easier it is later on to have not competitive standards on the market. So, thank you very much.